All right, so we're back with another interview here live on Eigenlayer, and today I'm joined by the Hexagate team. And before I try to explain it and mess it up, I'll just let Aviv introduce himself and then let him give a quick explanation of what they're building and how it works.
Yeah, great. Just want to say, first of all, thank you for having us. It's great to be here and have the stage to talk about security, which we think is very important. Um, so, as Nader said, my name is Aviv. I work at Hexagate for the past year. Uh, my background is a more classical cybersecurity background, hacking stuff on the internet. Uh, and here at Hexagate, our mission is to make Web3 safe and secure for everyone, and we really believe in what we do. Right now, we're mainly serving the largest players in the industry, protocols, bridges, asset managers, customers like Coinbase, Consensus, Eigenlayer, of course, Kion, GMX, Uniswap, Renzo, Puffer, I can go on. The biggest names. And our mission, we're a real-time monitoring platform. We look for exploits, phishing, fraud, any other malicious activity that are happening on chain. And our mission is to stop those before they are able to steal any funds from the users.
Well, sounds like a very big challenge. So I'm ready to dive in and I'm excited to learn more. I think that in 2022 and 2023, there was just so much happening, not only with the market itself, but there was a lot of hacks happening. And I was starting to just question the potential for smart contracts to hold like large sums at that point. And mainly because of just the fact that if you have one minor bug or something like that, then you can be exploited. Now, I know that the longer we have best practices, the more those things that do go wrong, and people can learn from those mistakes. That the engineers they learn best practices, but there's obviously always potential for things happening. So I think there's a lot to discuss here, but I'm curious to learn exactly how Hexagate approaches this and what it looks like in practice for developers. And I think we're going to dive into some presentations and stuff. But if you want to kind of give a brief, slightly more in-depth explanation of how people are using Hexagate.
Yeah. So first of all, what you say is very true. Mainly the part that anything can always happen. In the Web2 space, like in classic cybersecurity, there are a few dozens of years of experience by this point. People know that you can always get hacked. You cannot say, oh, some amount of hours of researchers have gone into looking at my code, so I know it's safe and nothing bad will happen to me. And I think, at least for some people in the Web3 space, that's still the way of thinking, that there is one thing that I can do or a few things that I can do, and now my contract is secure. And unfortunately, I hope that people are now coming to the conclusion that's not the case. And the way we think about security in Hexagate is layers. You can never be too safe. And by stacking these layers, that maybe some of them have holes somewhere, but you have enough layers, enough mitigations, always think about security and have different products that try to cover each other's weaknesses. You can build a security stack that hopefully would help you save funds and avoid being exploited. And one thing to keep in mind is it's always a question of cost effectiveness, security that is. And I mean by that is if you have a lot of TVL, you are a target. And there is always a vulnerability hiding somewhere. I think all security researchers will agree that there is a vulnerability somewhere in Geth, somewhere in SolC, and it's all a question of, is there a big enough target that cyber criminals are going to spend those hours and days and years of researching to find that vulnerability and steal the funds. So when you try to secure yourself, you always need to ask yourself, how can I be a less cost-effective target? How can I increase those security layers to make those cyber criminals look at my protocol and look at my setup and say, maybe I should research something else.
That makes sense. So when did you all decide to start working on this, on helping solve this problem? And how long ago was that? And just curious how the team came together.
Yeah, so Hexagate is about 2 years old, depending on how you measure it. But from the start, the main aim was there is this brand new space. Attacks are happening all the time. We have a team that is very versed in cybersecurity, and we wanted to take this expertise into the blockchain space and see how can we enrich and lead this new wave of security products and security companies that are coming to help and alleviate these attacks. So the mission from day one was we are going to be the best in the space, and because there is real money on the line, and we see that as a real goal to try to make this space usable from a security and risk mitigation standpoint.
So when you started building this, it was, I guess, 2022.
Yeah.
Got it. Did a lot of the team have smart contract experience, or were they coming from other like security backgrounds? Or both, maybe?
It's a mixed team with mixed experiences. I think mostly from a classic cybersecurity background and less the blockchain space. But we feel like this background has translated very well into this new space, and I guess some of our philosophy as researchers is that if you're a good researcher, you can apply this into any field. You can be a good CPU researcher and a good blockchain researcher, and it's mainly about learning the space so you can apply the skills you've learned as a security researcher and look at this new space and use the same tools that you have used to analyze and find vulnerabilities in previous products.
Got it. So when I heard about Hexagate, like in theory, it sounded interesting and it sounded obviously valuable, but in practice, I was like, how does this actually work? But when I saw the demo, it made a lot of sense, and I thought that the thing that stood out, or one of the things that stood out a lot, was kind of like the UX. It was like I thought it was a pretty nice UX. So do you want to kind of dive into what it actually looks like to use Hexagate, and how it would kind of work into the workflow of someone's engineering, team, and their day-to-day operations?
Yeah, so I think we'll start with first giving a sense of what it means to monitor and what can you monitor and why should you do that. And maybe later we'll try to dive into how to practically do that. But I think our time will be better spent at start at least to give an overview of how vulnerabilities work, how can you monitor for exploits, things like that.
That makes sense.
Yeah, so first I said that we should think in layers and cost effectiveness. First layer I wanted to talk about is like general threat monitoring. And what I mean by that is we're not the only company to do this. You have a lot of transactions that are happening all the time, and you can employ machine learning and other heuristics to look at these transactions and try to flag which transactions are exploits or seem very abnormal. And I wanted to give an example of a vulnerability and how an exploiting transaction would look like to give you an idea of why that is possible. Because if you go to someone from like a classic security background and tell them, yeah, I have a machine learning model that looks for exploits, they say, no, you don't, because that's very hard in the classic space because you have a much more complex processor and things like that. But in the blockchain space, I wanted to give a brief overview of why that would be better. So I would like to show you maybe a few seconds of a game I like to play called Find the Vulnerability. Basically,
It sounds fun.
yeah. Can you see I'm sharing a tab, right, with a picture?
Yes, I see it.
Yeah, so this is a classic function ERC20 transfer. This is from a token which will not be named.
This is a real exploit.
Yeah, this is a real exploit that we've discovered a few months ago. And I would give the audience maybe 30 seconds to look at this. The main target of this function is to take balances from the sender, move them to the recipient, check for that the sender has enough balance, all of these stuff. So I'll give you a few more seconds. Cool. So an auditor or someone just casually browsing through the code might look at this and say, okay, this is fine, because the security vulnerabilities are sometimes hard and they takes a little bit of luck even to look at something and have the right state of mind at the right time to find the vulnerability. In this case, the questions I want you to ask yourself is what happens if I try to transfer funds from myself to myself? So sender and recipient is the same address. That's my address. So you can go through the code line by line. We take the sender amount and the recipient amount, which will be exactly the same amount because they're the same address. The check is fine. And then when we update balances, we first, at the first line, balances sender, which is my balance, equals to the previous amount minus the new amount, the amount that was transferred, which is fine. But the next line, balances recipient, would actually overwrite what the last line did because sender and recipients are the same address. So basically, the last line would be basically irrelevant, and what would actually happen to the balances is that it would be the old balance plus the amount that was meant to be transferred. That's a
It
pretty
seems
classic.
obvious after you pointed it out, but I didn't catch it.
Yeah. As I said, you have to be. You can look at this function 100 times and not find it, and you can look at it for the first time and say, of course, that's obvious. Research always has a little bit of luck in it as well. So in this example, I hope you can see that if I, in a loop, maybe call transfer to myself, I can basically mint an arbitrary amount of tokens and basically exploit if they have a Uniswap pool or something like that, and I can steal all the funds from there. The reason I showed you that, except for the fact that it's cool, I think, is to show you how an exploit looks like. If you see the trace, this is a token called GPU that was hacked a few months ago. The trace for this method was there's a flash loan above that you can see, and then in a loop, we call transfer from myself to myself, and you can see the amounts on the right-hand side is doubled every time. So you double the amount every time until you have an absurd amount of tokens, and then at the last, you can see Pancake Router swap exact tokens for token. You swap whatever's in the Pancake pool to get WETH or whatever that was, and you stole everyone's money from the pool because you minted an arbitrary amount of tokens. So obviously, this trace looks very abnormal. There's a flash loan, and there's a call from myself to myself, which never happens in a transfer. It happens in a loop a really long amount of times. The gas price is really high. I hope you can see that a machine learning model that looks at all the transactions in the blockchain would look at this and say, whoa, that is very abnormal. Maybe something bad has happened. Given that you have a model that can do that, you need to ask yourself, well, what then? So I've detected that an exploit has happened, but it has already happened and all the funds are lost. That's a criticism that monitoring companies get a lot of the time, which is true. It's valid. There are exploits where detecting them would not help. The other side of that is that detection, first of all, can happen earlier than the transaction itself. If you have an exploiting contract that is deployed on chain, you can analyze that contract, you can simulate their transactions, and you can try to, ahead of the exploit itself, find the patterns that say, oh, an exploit is going to happen based on the contract that was deployed. And also, some hacks happen not in one atomic step, but in several steps. Sometimes attackers would only steal a small amount of funds to see that it works and wait an hour, and after an hour make the large attack. Why? I don't know. That's like more of a criminal psychology than cybersecurity, but it happens. And this approach has proven to save funds in multiple occasions and to detect exploits in time. And again, if I go back to the start of this talk, you have to think in layers. Okay, this method might not save all the exploits all the time, but if they can save some funds some of the time, there's no reason not to employ this as well as other methods, because there will not be a silver bullet that would save all exploits. So this is one layer in the security toolbox that a protocol needs to have, because why not, basically? There's no downsides. So yeah, this is like, if I summarize this first layer of security, that would be general threat monitoring on-chain, try to detect exploits. And once you detect the exploits, there are several mitigations that you can do. You can pause the protocol, you can contact security experts, authorities, etc.
I guess being able to identify what those sorts of actions, or not really actions, but what are the sorts of red flags that would be worth monitoring would be something that is also maybe like a learned skill, or maybe it's more like if you're already familiar with the protocol that you're working with, or specific types of functionality that might be implemented across various smart contracts, then you can kind of know what to look for, and also how to prevent massive state transitions, I guess you could say, even before being able to create some type of pausing action.
Yeah, so for the specific protocol behavior, that's actually a second layer that we're going to talk soon. This method is applicable even if you have no idea what the contract does, because you've analyzed the entire blockchain history. It's open since Genesis. You can download all the transactions from the Ethereum network and analyze all of them. And if you have a good enough database of here are examples of exploits, you can train a model that will look for these abnormalities. Even if you have no idea what the protocol does, if it looks like an exploit, it could be a false positive, but it might be an exploit. So yeah, I will move on to the second layer that we've touched on briefly, which is well, general monitors are general, right? But there are also more specific monitors that are dependent on the exact protocol, their use cases, and its behavior. For example, if my protocol is upgradable, someone stealing my private key and upgrading my contract would not look abnormal, just look like I've upgraded my contract. There's nothing on-chain that looks abnormal about someone using my private key and upgrading my contract. There's no way of differentiating between that actor stealing my key and me using my own key, usually. But I know, because it's my protocol, that upgrading is rare, and I want to get a notification when that happens, for example. I want to get an information alert. Whenever my protocol is upgraded, give me an alert. And someone being on call in my company or foundation, whatever, can look at that and say, yeah, that's us. That is our upgrading our contract once a year. Or it could be that the on-call looks at that and says, oh, wait, that's definitely not us. Something has gone terribly wrong. And this few minutes, because yeah, maybe 10 minutes later, someone will post it on your Twitter and you will learn that. But those 10 minutes might be critical. And if you get that alert the same second this upgrade has happened, that might give you enough time to pause, do any remediation process, blacklist that key from your multisig, I don't know, any kind of things like that. So that's like a basic example of knowing your protocol and mapping the specific assumptions, security assumptions, risks. But there's a buzzword called invariants that pops up from time to time. And invariants are like more deep and hard and complicated example of monitoring known threats. If I know my protocol, I know the inner workings of the code, I can look for behaviors or conditions that must always be true. For example, if I take an ERC20 token, you have the balance of each token holder, which is a number. You have a mapping of each of those balances. And you have another variable in the ERC20 contract called the total supply, which should be the sum of all of those balances, right? The sum of all balances of the token must be always equal to the total supply. You can say that this is an invariant of the ERC20 implementation. It is interesting to monitor these kinds of invariants because usually when an exploit happens, it usually means that an invariant was broken. Because the invariants are what holds the inner logic of the code in place. And breaking those invariants, in the case of ERC20, for example, probably means that someone was able to arbitrarily mint or burn tokens without going through the obvious method. In the GPU token example that we looked at earlier, it was arbitrarily minting tokens without changing the total supply, which would flag an invariant in this case, even if in this case the trace was abnormal. So we would get two alerts, one from the general threat monitor and another from the invariant monitor. But that you can see the two layers, and if one of those layers would not work, we have the other, so that's good.
Nice. That makes
another
sense.
classic invariant example is the bridge example. Usually when you have an off-chain bridge between two networks, you deposit funds on layer 1. Let's say Alice deposits 100 tokens on layer 1. There's an off-chain entity that looks at the deposit and says, okay, someone deposited 100 tokens on layer 1. I should, as the centralized operator of the bridge, mint 100 tokens for Alice on layer 2. Usually how a bridge works, you have an off-chain entity looking at the first layer, it deposits, and then makes the operations on the second layer to create or mint the same amount of tokens on the other network. An invariant that comes from this behavior is that for every withdraw or mint on layer 2, you must have a matching deposit on layer 1 with the same address and the same amount. If you don't have that, someone was able to abuse your bridge to arbitrarily mint tokens on layer 2. And that's another invariant that you can monitor. For example, the wormhole hack that happened in 2022, wormhole has a network of guardians that are like the centralized operators that look at the first layer and mint in the second layer. And someone was able to bypass the signature validation of the guardians and arbitrarily mint tokens on layer 2 without having a guardian signature. An invariant that looks for the matching deposits on the first layer would catch that because you have a withdraw on the second layer without a matching deposit on the first layer.
So in this case, it's working, between different smart contracts and coordinating some type of functionality between the two, as opposed to just one. Because in my head, most of these use cases would be just within a single smart contract or within a single deployment. But I guess they can work across multiple deployed contracts across multiple networks.
Yeah, I think the most complicated exploits happen when you have assumptions made between different components in the blockchain or even between different blockchains. You can think about Oracle manipulation as an example. It's not an exploit in the token itself or the DeFi protocol itself. It happens in the connection between different components of the DeFi ecosystem, different assumptions made about every side of the interaction.
Right. Okay. That makes sense. Yeah.
Yeah. And I wanted to give you maybe a quick example of how, okay, I can map these different invariants. I can ask my security team or the auditors of my protocol to map these invariants, but what am I supposed to do with them? How do I monitor them? And I wanted to showcase, I think, pretty cool language that we've developed called Gate, which can be used to define and monitor these invariants every block. So I will do the thing that is forbidden, which is live coding examples, which never always go wrong, but we will try.
You get credit just for trying no matter what happens, but I have faith.
Yeah. Okay.
Is it okay if I go ahead and bring the terminal on stage?
Yeah, that's fine. Okay, I have a cheat sheet in case something goes wrong, which is fine. Yeah. Okay. So the invariant we're going to program today is invariant in USDC. USDC has a blacklist functionality, and an invariant that comes from blacklist functionalities is that every transfer cannot be made from an address that was blacklisted, right? If I blacklist an address, that address cannot be the from address of a ERC20 transfer. So we are going to try to monitor for that. First, we're going to take the USDC address. The way Gate, which is our language, works is by defining data sources and then defining invariants that have some conditions on these data sources. And then this query can be monitored every block. So let's start by having the USDC address, which is an address, and it is this address. And then we want to get every block, we want to get all of the transfer events, right? So let's take transfer events. It is going to be a list of address. I will explain this in a second. Address, and integer. And it's going to be all of the events of the USDC contract with this exact signature.
And real quickly, I see test.gate. So we are working in a new programming language, essentially.
Yeah, it's not really a programming language because you don't have, it's not an imperative language where you have loops and functions and conditions. It's more of a, it's more like, it's useful to think more like HTML or and less JavaScript. Like it's a descriptive language where you define the different operations that you want to be performed, and there is an engine that is performing these operations every block.
Makes sense. Okay, cool. Very easy to read though.
Great. That's good to know. So this data source basically says, give me all events, every block, give me all events in this block from this contract with this signature, basically all transfer events. And let's use, we have to get the event data source from Hexagate. And right now, I will just as a quick loop, invariant blocks have a description, which basically say what they do. Right now, just say USDC invariant, and have a condition. And that's just for an example, that's not the final invariant, but just let's say that I want the length of the transfer events to be greater than 0. Condition. Great. Basically, our invariant right now says, get all transfer events each block and ensure that there is at least one transfer event each block. That's not a real invariant because, of course, blocks can have no transfer events in USDC. But because USDC is a very popular token, I guess that if I would just go ahead and run that, yeah, you can see at the bottom invariant passed, and that's the trace. And we can see that indeed there was an event, even more than one. And you can see the address of the sender, the recipient, and the amount. And of course, we have a much better UI for that for our customers. This is just like a quick demo that I've done for this talk.
Which block was this run on?
The head. It's always from the head block. We can check, but if I run that again, it's probably going to be on a different block.
But in practice, it's basically going to be running on every block.
Yeah, if you define a monitor using Gate, then that monitor would be run every block, yeah.
Nice.
And the idea is that if your invariant is broken, you will get an alert.
And then you can also, well, I guess we're going to go into that. I'm not going to ask the questions now. I'm going to wait.
Okay, sure. So now we want to ask for each address that was transferring, is that address blacklisted? Now, to do that, we need to get all of the blacklist events from Genesis, which sounds too hard, but in Gate, that's possible. So you can get all blacklist events, which is a list of addresses. which is historical events, which is a different data source on the same USDC contract with this signature. This data source is going to give us all of the historical events from Genesis of every address that was ever blacklisted on USDC. Now, because it's in a tuple, because events give you like the tuple of all parameters, so let's just do a quick manipulation, all blacklisted addresses, which is a list of address, and we're going to have event 0 for event in all blacklist events. Now we have everything we need, and we're just going to ask any blacklisted, which is going to be a list of addresses, is going to be the, let's do for event in transfer events. We get the event 0, which is the from address, and we're only going to include that address if we'll have a new data source here, if that address exists in the all blacklisted addresses. That was a bit more complicated, but basically all we're doing here is we're going through the transfer events, which are the USDC transfers that's happening every block. And we're asking for each of them, does the from address, the sender, appear in all the addresses that were ever blacklisted in USDC? So that list should be empty, right? Because all addresses that transferred money in this block, none of them are supposed to be in the all blacklist event. If any of them were in the blacklist, that we want to flag like an alert. So we can change our invariant condition that the len of any blacklisted should always be 0. And we can monitor that every block. We can run that. I need to get historical events. That's fine.
So now you're monitoring?
Yeah, so this is an example run from the current block, and you can see any blacklist empty, and all blacklist addresses is all the addresses that were ever blacklisted, all blacklist events, and transfer event is the current transfers in this block. And this is good. If we have anything in this list, that means that the transfer event that happened in this block included an address that was blacklisted, which should never happen. So I hope that I've given you like a quick example.
What is the all blacklisted events array coming from again?
Yeah, so there is a data source here in Gate called historical events, which looks for all events since Genesis of this contract with this event. Basically, a USDC can blacklist addresses, and this operation creates the blacklisted event in the blockchain. And using these circle events,
that data is just available for you.
Yeah, because it's available in the blockchain, even though it's a lot of blocks to look for, we have a very strong indexer, and we're able to do that request pretty efficiently.
Makes sense.
Yeah, so I hope this is an example of what can you, a few things. One, what Hexagate can do, and two, what can you do with invariants? Let's say I map these invariants, so using a system like this, you can monitor these invariants every block, and hopefully these alerts should never fire, but in case something bad happens, you can get these alerts.
And I'm guessing like in the real world, people are hooking into these events via some other system, and then they're actually doing the pausing of the contract or whatever programmatically.
Yeah, so basically in our system, you can hook up every monitor, not only invariant monitoring, even general thread monitoring or custom monitoring, like notify me whenever this contract is upgraded or whenever this function called this whatever. You can connect each of these alerts both to an alert channel, so like you can be notified on Slack, on Upstreamy, whatever your method of getting alerts, Telegram. And you can also combine these into automated responses. Like I want to say, whenever this alert happens, that is 100% bad, I want to automatically pause, you can do that. you can hook that up to like a webhook that signs a POS transaction and sends it to the blockchain.
So what is the, I guess, user experience like? Can we kind of talk about that a little bit more? I think that was one of the things that I mentioned earlier that I really liked. We don't have to do a live demo or anything like that, but maybe we can just explain kind of how this looks like in practice, because I think like we understand how the tech works, we understand like some of the different things you can do, but how would this actually start being used in someone's in someone's system, and how could they essentially just add it to their existing architecture and workflow, I guess?
Yeah, that's a good question. Basically, when customers have like the main web app application, and from there they have a pretty convenient dashboard where they can set up whatever monitor they want. They have like different categories. For example, you have the general threat monitors that we discussed, which is like, give me a bunch of addresses that are your assets. It can be your pool, your DeFi pools, your assets that you rely on, your price oracles, your multi-sigs, administration things. And we can take all of these addresses and monitor them using our general threat monitoring system. And whenever we detect an exploit or an abnormal transaction that uses any of these addresses, you can get an alert in whatever method you choose, be it alert or automated response, whatever you want. So that's like the first monitor you can create. You can also create custom monitors, which are basically custom English sentences when you can say, notify me whenever this contract does this thing, whenever the balance of this vault drops by 10% in the 24 hours. Like different sentences that you can construct.
So when you're constructing these sentences, is it turning it into the underlying language using some type of like AI stuff, or is it more like?
No, it's more like a UX thing that you have a
Okay.
dynamic component where you click on that, you say more than, and then like you
Oh, okay,
construct.
got it. Yeah. So it's like
And of course, if any listener wants a demo, we're here, and we would be happy to show anyone.
Yeah. So how
And
many? No, I'm sorry. Go ahead.
I just want to say the last thing, you have the general monitors, you have the custom monitors, and you have invariant monitoring, which is basically you have a nice UI when you can write invariant in the Gate language that we've shown, create these monitors, and basically the same thing.
So you mentioned before that EigenLayer, we're working with Hexagate. Can you kind of talk about some of the other teams that are that you're talking to already as well? I know you mentioned it as well earlier, but maybe touch on it again, and then give us an idea of how many different teams are using it total.
Yeah, definitely. So as I said, we have pretty big names besides EigenLayer, which are a very heavy user of our invariant monitoring. Actually, they also helped design some parts of it. We also have Coinbase, which is a partner both in the base side of things, also in smart wallets, basically all over the Coinbase ecosystem. Consensus, both in MetaMask, in Linea, and all kinds of those things. We have Kiln, which are a pretty big staking company, both in the Kiln on-chain staking and other products. Also have exchanges like GMX, Binky, those kind of actors. Uniswap. We also have a lot of other restaking actors like Renzo and Puffer, which are customers. And these customers use like a variety of services. Some are more in the general threat monitoring. Others dove really deep into invariant monitoring. Each customer like takes whatever they need. And our platform, I think, is very diverse and able to accommodate whatever we need. Coinbase also, we've done a war game recently. They're developing like the fraud-proof system in Optimism, and that's a very big upgrade. So we've done a war game, and actually our invariant monitor has flagged something in the war game, which was very, very good to see. So overall, very big names. We also have a lot of other companies that I haven't mentioned. I guess the number of customers overall is probably over 30, but I haven't counted lately.
Yeah, no, that's amazing. Congrats. It sounds like some really great clients, especially for, I guess, how young your company is. But it is in my experience and what little I've kind of like looked into it and talked to some of our team members, seems to be really great. What is the future plans for Hexagate over the next, like, let's say, year to 2 years?
That's a very good question, actually. The last layer that we haven't mentioned yet is on-chain mitigation, which is something that we have started delving. We have some products that are ready and some that are waiting to be made. Because on-chain mitigation, all the things I've talked recently in this talk was mainly off-chain monitoring. And in contrast, on-chain mitigation is something that is much more direct. If you can give contract the tools to say, oh, I am being exploited, I want to revert this transaction, that is much more direct. It has the limitations of being on-chain. You have limited data availability, limited compute resources. You don't have access to historical data like you have off-chain. But it is much more direct and much more powerful. And there are some more low-tech and more high-tech solutions. The simple example of an on-chain mitigation, which we think is very powerful, is actually something that Eigenlayer is doing, which is delayed withdrawals. The system of any withdrawal from our protocol needs to have a delay so that off-chain components like monitoring and security researchers can look at that and say, oh, this withdrawal should never have happened. This is a result of a hack. The fact that the Eigenlayer team has enough time to look at these and react in time and not have to chase the attackers, that is the simple and very effective means of another security layer, as if you use this terminology we've been using. Another a little bit more sophisticated example is another product that we've been developing called Gator, which is a way of analyzing smart contract interactions since Genesis, like looking at all the interactions a certain contract like a DeFi protocol has made, and trying to map all of the legal interactions and uploading that to an on-chain database so that the contract can check while an interaction is being made, hey, is this interaction new? If this interaction was never made before, this chain of functions was never called before, that's a pretty good indicator that something is probably wrong. And hey, if that's a false positive, maybe you can revert that and then contact the developers and we can whitelist it. But usually, like a vast majority of the cases, exploits are a novel way that a contract is being used. And if you can detect that and mitigate that on chain by having a database of allowed interactions, so to speak, that's a pretty good on-chain mitigation to help solve some of the exploits. So that's like another way to do on-chain mitigation. And more in the future, we're trying to think about how do we do like a more blockchain native, decentralized security product by having like a network of validators that can check invariants or machine learning models, and like doing something like that on chain where you can have incentives for operators to run security checks for the protocols, and somehow have this maybe integrated in different parts of the network. So these are the main things, apart from like supporting more chains. Like we're recently starting supporting Solana, which is very different from EVM-based
Oh,
chains.
wow.
So
Yeah, that has to be completely different. Did you have to build a lot of new things from the ground up?
Yeah, we're still in the early steps of that, trying to take it one step at a time. But yeah, we're expanding in all kinds of different directions and trying to really make Web3 safe for everyone. So that's a pretty wide audience to please, I guess.
Yeah, this has been really great. I think that the two final questions I have would be, first of all, I know that if you want to start using Hexagate today, you have to contact and you have to get in touch with someone and get onboarded manually. Will you all be moving to more of a permissionless system anytime soon?
That's another thing that we've been considering. That's a pretty big step forward in terms of like you need a team to manage the customers and have like it's a pretty different way of thinking as a company, I guess. So we're definitely considering that. We want to do that. We want to be able to give this service to everyone because it really fits our agenda. And it's something we'll definitely do in the future, but we still need to understand exactly how that would happen.
Okay, and the last question is, if someone wants to use Hexagate, what's the process to get started?
Yeah, so basically, we would love if you would contact us. We have a Twitter handle, we have an email, you can visit our website, you can have contact info there. Basically, whatever method is comfortable for you, give us a call. We would be more than happy to go on a call with you, do a demo, discuss how we can help you. And our customers know that we're more than give you a platform and good luck. We're a very hands-on approach. We talk to our customers. We do war games. We do meetings. We help customers map invariants. We want to really be security partners for everyone that we're involved with. So that's, and we can also share this link to contact us, which I've just received through a channel. So yeah, this is a link. I don't know how to share that with everyone, but
okay, yeah. Let me see here. I'm going to post the link under the tweet that went out when this episode went out.
Great.
So I'm going to post it there now. That's probably the best way that people can find this in the future.
That's great.
So this is basically the link to sign up or to contact you.
Yeah.
Okay, cool. Perfect. Just added it there. Awesome. Well, this has been really great. We hit, I guess, almost 50 minutes. So this has been a lot of like really interesting stuff that we chatted about, though. I don't think we've talked about anything even close to this yet on any of these interviews. So that's been really a nice change. So thanks for your time today. If anyone wants to also follow them, the Twitter handle is right there on the screen, Hexagate _. This week, we're also bringing on Dan Romero from Warpcast and Farcaster, as well as the Versatis team from the ABS Versatis. So looking forward to that. So keep an eye out for those videos and those streams coming up soon. And that's it. So thanks for stopping by.
Thank you very much. It's been great. Thank you.